year is 2022. Humanity is on the cusp of some incredible discoveries. Yet for all our advanced technology, we're still locked in an endless struggle to survive. Natural disasters strike more frequently than ever. And worst of all, there seems to be no hope of leaving Earth. Space exploration has ground to a halt. But what if there was good news from the world of science? What if I told you that one day soon, humanity could escape from dying Earth and colonize the entire universe? That's right. According to some scientists, the universe itself is expanding at such a speed that one day, any intelligent life form will be able to travel to any other star system without spending hundreds of thousands of years hurtling through the darkness. So sit back and prepare to have your mind blown as today we explore the awesome power of dark energy. Now, before we start, you need to know that this video is just under 100 images. And now, welcome to my channel. Have you ever looked up at the night sky and wondered just how big the universe is? From the brightest star to the farthest galaxy, each point of light is unimaginably distant. And when you consider that space is constantly expanding, it's hard to wrap your mind around the sheer scale of the cosmos. Scientists have estimated that the universe is roughly 94 billion light years across, which means that it would take a photon traveling at the fastest possible speed a full 94 billion years to cross the universe. And that's just the size of the observable universe, which could be a lot smaller than the actual universe. But what's really mind-boggling is the fact that the universe is getting bigger every single second. And the force that's responsible for this is called dark energy. Dark energy is a mysterious force that makes up nearly 70% of the entire universe, yet we can't see it, touch it, or directly measure it. Like dark matter, we infer its existence indirectly from its effects on the things we can observe. For example, we know that the universe is expanding because distant galaxies are moving away from us. The farther away a galaxy is, the faster it's receding. And that means that space itself is stretching, carrying the galaxies along with it. But the strange thing is that the expansion of the universe is speeding up, which means that dark energy is growing stronger. And we don't know why. Dark energy was first detected in the late 1990s when two independent teams of astronomers were studying distant exploding stars called supernova. These supernova are incredibly bright and can be seen billions of light years away. Scientists use them as what's known as standard candles to measure the distance to other galaxies. By comparing the brightness of a supernova to its redshift, which is the amount by which its light is stretched due to the expansion of the universe, astronomers can calculate how far away the galaxy is. One of the teams was studying supernova in distant supernovas to see if they could measure the rate at which the universe was expanding. Their expectation was that the expansion was slowing down due to the gravitational attraction between galaxies. But their measurements suggested that the expansion was actually speeding up. This discovery came as a shock to the scientific community because it implied that there was some kind of repulsive force pushing the galaxies apart. A force that was even stronger than gravity. At first, scientists thought that there might be something wrong with their data, but further observations confirmed their original findings. Today, most cosmologists agree that dark energy is real. However, they don't really understand what it is or where it comes from. There are several theories about what dark energy might be. One is that it's a property of space itself. This is known as the cosmological constant. Einstein originally introduced the cosmological constant into his theory of general relativity to make it work with a static universe. However, as we now know, the universe is expanding, so Einstein discarded the constant as unnecessary. But some cosmologists have suggested that it might be real after all. Another theory is that dark energy is a dynamic field called quintessence. This field would have a particle associated with it, but it would have to be a particle that hasn't yet been detected. Finally, there's a theory that dark energy isn't real at all, but that our understanding of gravity is wrong. This idea is known as modified gravity. It suggests that the effects we attribute to dark energy might actually be due to a modification in the way gravity works on very large scales. Unfortunately, none of these theories have been proven. Indeed, scientists are struggling to come up with experiments that could test any of them. The difficulty is that dark energy is so weak that it's almost impossible to detect. Most of the evidence for dark energy comes from observations of the cosmic microwave background, the afterglow of the Big Bang. The pattern of temperature fluctuations in the cosmic microwave background provides some of the strongest evidence for dark energy. The fluctuations in temperature are thought to be caused by quantum fluctuations in the early universe that were then stretched by the expansion of the universe. The pattern of these fluctuations meshes well with the predictions of the standard model of cosmology, which includes dark energy. Other evidence for dark energy comes from the study of distant supernova. As we've already discussed, the supernova appear to be accelerating, which implies that there's some kind of repulsive force acting on them. However, this evidence isn't as strong as the evidence from the cosmic microwave background. Indeed, some scientists have argued that the supernova data can be explained by other means, such as a modification of gravity. Still, the majority of cosmologists believe that dark energy is real. And if it is, it could have a profound impact on the ultimate fate of the universe. Some scientists believe that dark energy could eventually cause the universe to rip apart in a process known as the Big Rip. In this scenario, dark energy would continue to grow stronger until it is powerful enough to overcome the gravitational forces that hold galaxies together. Galaxies would be torn apart, then stars would be ripped apart, then planets, and then atoms. Eventually, the entire universe would be completely destroyed. Others believe that dark energy could cause the universe to collapse in on itself in a process known as the Big Crunch. In this scenario, dark energy would eventually begin to weaken. As it weakens, gravity would become the dominant force in the universe. Galaxies would begin to collapse, then stars, then planets. Eventually, the entire universe would be compressed into a single point known as the singularity. At this point, the universe would begin to expand again, restarting the cycle of cosmic evolution. Finally, there's the possibility that dark energy will keep the universe expanding at a constant rate forever. In this scenario, known as the heat death of the universe would expand, cool, and darken as stars die out one by one until every single star in the night sky goes out, leaving humanity in total darkness. What do you think will happen? Will the universe rip apart, collapse, or simply expand forever? Let me know in the comments below.